Alright, so hello everybody. I'm Nick,
And I'm Nicholas.
I'm D here.
and this is our physics motor project.
Today we're gonna be talking to you guys about how we built our motor, like what materials we used and how we optimized it, as well as how you can build your own motor.
And as well as how much of a budget we were on.
Alright, so this is how we optimize the performance of our motor. Alright, so first off, we started off with a smaller, shorter solenoid that is inversely proportional to the magnetic field, which allows it to spin faster with more efficiency. Next off, we used stronger magnets to increase that magnetic field to also make it have a stronger spin. And lastly, we used a small, long metal rod because between the L brackets, the holes, it will have less friction, which means it could spin faster again with more efficiency.
So the best materials to use for while doing this project are basically all right here, but we could always improve, right? So what we used in our video were these ceramic blocks. They're really strong. They're only like $8, so that's good. And the next thing we used were these L brackets to hold our magnets and our rod, and to allow it to spin. Another thing we used were really good copper wire, and we used a lot of it so to have the most maximum current going through the thing. And for brushes we used paper clips, but we should definitely, for when you guys are doing this, you should always use copper brushes as your commutators.
Alright, so we're going to explain the choices of the materials and why. Alright, so starting off, these magnets, ceramic. The reason why we chose these, we wanted the strongest possible magnets for as low of a price as possible, so we went with ceramic blocks, around $8. So then off we went to a thin metal rod. Why we chose this? It's thin, very little friction between these L brackets here, which I'll explain next. Now these L brackets, very stable, able to be bolted down to wood easily, and the reason why we chose these is because they're very stable and they're aesthetically pleasing. Next up we have this cardboard here. Wood could have been used, but however, on the strict timeline we were on, cardboard was our best option. Next up, this copper wire provided by the teacher. Why we chose this over another copper wires, we found it was the most efficient and easiest way. Next up, these paper clips. Paper clips were used because they provide an easy and efficient way of delivering electricity to the commutators. Next up, electrical tape. An obvious answer why we used electrical tape was just to provide more traction and more thickness to the metal rod, and to also allow electricity to conduct from these paper clips here to the commutators. Then also, this wood block at the bottom provides a stable base for the whole motor itself.
So, now I'm going to explain how we built our motor itself. So first, I got the metal rod, and I attached a rectangle of cardboard on each side of the metal rod, so it closed it off. Then I took two square pieces of cardboard, which you can actually see right here, and attached them on each end of the other two pieces of cardboard, so it would close off, so it would hold in all the wire when I would put it in. So then I inserted the metal rod inside of the two arm brackets, because obviously the arm brackets were already attached. We used nails to attach the arm brackets down onto the wood, and then I inserted the metal rod. I then put two pieces of tape on each end so that it would stop the metal rod, so that it wouldn't go all the way through, and it had a nice stopper. Then I also had to add tape on the metal rod itself because we had a problem. The metal rod was too thin. We had to make it thicker so we can attach the commutator later down the road. So we added tape around it so that we can make this rod a little bit thicker. Then we began to wrap this with the coil, and we have to wrap it 65 times on each side so that the current would come through evenly on each side. And yeah, Then I took the extension of one wire from each side and I folded it back to make 2 wires over here and here. These act as the commutators, which will send electrical current into the wires and send it through the coil. Then I had to attach 2 magnets on each side, aligned with the copper itself. This will create the magnetic field for the motor itself. Then we had to use paper clips down here so that act as brushes for the commutators. Basically, we hook up the alligator clips here and here, and then the current travels through the paper clips into the commutator, and basically when the magnetic field interacts with the copper and the coil, it spins because there's a downward force acting, and then upward force acting, and downward force, and then upward force. And the force is created when the current travels one way, the magnetic field is traveling the other way, and they're all perpendicular, and therefore a downward force is created. If you use the third right-hand rule, you are able to determine which way the force will go. Yeah, that's it actually.
Okay, so now we're going to talk about the cost and how we managed to pull it off in such a low budget, right? So, as you can see, we spent about like $20 on this project, and you should spend no more. You could spend more if you want, but that's okay. So let's talk about the prices. So as you can see, these magnets were about $8 per 2, and that may be a little bit too much, but the magnetic force they applied to our project is a lot. The next thing I want to talk about is the out brackets we used to hold our magnets and our rod. These were about like $7, right? And the screws were free, obviously. And another things we used were this rod to hold our motor in place, and that was about $3. And the copper wire was provided by our teacher, and the electric tape was also provided by our teacher. And the paper clips were about $1.
Alright, I'm going to explain why our motor did not work. So we initially had 2 designs, one with a three-directional motor and one with a basic solenoid. We believe the one reason why it didn't work was the commutators. While other groups were using actual materials like sheets of copper, hinges, and pop cans, we decided to go with copper wire, which ended up being the initial demise for our motor. And the reason for that is the copper wire is not strong enough to transfer that amount of electricity into the motor to get it moving. The reason we can prove this is because we had an initial jump start in our motor. When we first connected our alligator clips, the motor had a jump start, which we could prove that electricity was being transferred, but not enough.